Good morning everyone. I will be presenting my project titled Smart Energy Usage Optimizer, which is an IoT based system that reduces energy wastage in households. The idea behind these projects come from a very common problem we all face: rising electricity bills and wastage energy from appliances that are often left running unnecessarily. With this project, my goal is to show how we can combine Arduino Nano 33 and a Raspberry Pi to create a smart, automated, and cost-efficient solution for everyday household. I like to summarize the philosophy of this project with the phrase "power saved is power earned." Let me start with the problem statement. We often leave electrical appliances switched on even when they are not needed. Some common example includes fan running in empty rooms, televisions or set-top box left in standby mode, charges and adapter consuming what is called phantom power even when no device is connected. Now, why is this a problem? Firstly, it increases electricity bill. A single device might not only waste a few watts, but when you multiply that across multiple appliances and across the entire month, the cost becomes significant. Secondly, it has a global environmental impact. Electricity wastage contributes to higher carbon emission because most electricity is still generated from the fossil fuels till now. And finally, although there are commercial solutions such as smart plugs and branded homes automation system, they are expensive and often limited. Many of them only monitor usage, but they don't accurately optimize it by switching devices off automatically. This gap is exactly where my project comes in. The main research question guiding my project is how can a low-cost Arduino plus Raspberry Pi system be designed to monitor household energy use in real time, optimize use and automatically reduce wastage while remaining fault tolerant and responsive. Note that question is not only about measurement but also action and reliability. The system must not only collect data but also make intelligent decisions. It should continue working even if some parts of the system like the Raspberry Pi temporarily goes offline. This ensures that the solution is practical and usable in real world setting, not just in a lab environment. My proposed solution is an IoT-based smart energy optimizer. Here how it works in simple terms. Arduino Nano devices are connected to the household appliances. Each Arduino measures how much current the appliance is consuming using a current sensor. The Arduino also has a relay module which acts as a smart switch. If the system detects that an application has been idle for too long, that can automatically switches off. The Arduino sends all this data to the Raspberry Pi, which acts as a central server. On the Raspberry Pi, a dashboard displays real-time energy consumption, provides cost prediction, and even sends alert when unusual patterns are detected. The system doesn't just tell you how much electricity you are using, it actively optimizes your usage, which is the key innovation here. On the right side at the top we have the Arduino Nano 33 IoT. It is connected to an ACS712 current sensor which continuously measures the current drawn by the appliances. The Arduino calculates the power usage and can switch the appliances on and off using the relay. The data is sent from the Arduino to the Raspberry Pi for communication, and I am using MQTT protocol, which is lightweight, reliable and when suited for the IoT system. On the right, at the bottom, Raspberry Pi acts as the brain of the system. It stores the data in database such as MySQL and SQLite, runs an energy management program, and hosts a live dashboard built with the web framework such as Flask, Django, or Node-RED. From this dashboard, the user can see how much energy each appliance is using, predictions of their daily or monthly energy cost, alerts if application is consuming more than expected. This layered architecture, Arduino for sensing and controlling, Raspberry Pi for processing and visualizing, make the system modular, scalable and reliable. Now let me highlight some key features of the system. Real-time monitoring. The system constantly measures current and report power consumption almost instantly. Second, smart automation. Appliances that are idle are automatically switched off without waiting for human intervention. Third is cost prediction. Based on the reading and local traffic rates, the system can predict your electricity bill for the month. Fourth is live dashboard. The Raspberry Pi provides a user-friendly dashboard with charts and appliances status. Fifth, fault tolerance. If the Raspberry Pi goes offline, the Arduino can temporarily catch the data and then synchronize later when the connection is restored. Multiple device support. Because communication is via MQTT, you can have multiple Arduino units monitoring different appliances, all sending data to the same Pi. Together, these features make the system both useful for household and robust enough for real-life world development. The next part is hardware. The hardware for this project is simple but powerful. Arduino Nano 33 IoT, which has built-in Wi-Fi support and is perfect for embedded sensing. Raspberry Pi 4, which acts as the energy management server. ACS712 current sensor, one for each appliance is being monitored. Relay module, which controls the appliances based on the system decision. For upgrade, I can use the SCT103 clamp sensor, which is safer as it measures current without needing direct contact with the wire. The ZMP101B voltage sensor for more accurate voltage and power calculation, and a DS23231 RCT module to ensure accurate timestamp even if the Pi restart. This choice of hardware balances affordability, safety, and scalability. Now let's look at the cost. The basic setup, which is enough for distinction level, would generally cost up to 5,000 to 6,000 rupees, and the expected outputs and impact are significant. By switching off idle device, household could save between 10 to 20% on the electricity bill. Affordability. Unlike smart plugs or home automation kit, which are expensive, this solution is low cost and open source. Sustainability. Every unit of electricity saved reduces carbon emission, making this project environmentally impactful. Scalability. The system isn't just for one home. It could be used in hostels, small offices, and even community housing projects, so that the impact is not only financial but also social and environmental. To conclude my demonstration, I would like to say that the Smart Energy Usage Optimizer is an IoT-based project that provides a low-cost, reliable and scalable solution to a real-world problem: household energy waste. It leverages the strength of both Arduino Nano and Pi, combining real-time monitoring, automation, analytics, and fault tolerance. This project is not only just a prototype, it's a step towards making smarter and more sustainable homes a reality. Thanks for your attention.